Hi everyone, my name is Peyton Camden and I'm a meteorologist at the National Weather Service office in Springfield, Missouri. Today I'm going to be walking through eclipses. We'll talk about why they happen, how they happen, the different types, and how to stay safe when viewing an eclipse. Diving right into it, in order to understand why eclipses happen, it's important to understand the proportions and relative distances of all of the entities involved. Eclipses involve the sun, the moon, and the Earth. Both the orbit of the Earth around the sun and the orbit of the moon around the Earth are elliptical, meaning they're not perfect circles. That means at any given point in their orbits, they can be closer or further away from the body they're orbiting around. The size of the sun and the moon are not comparable. The sun is 400 times bigger than the moon is. However, it's also around 400 times further away than the moon, so how large they look to viewers on Earth can change depending on how far away the three bodies are from each other. Sometimes the moon's orbit brings it between Earth and the sun, which is when your eclipse would happen. Unfortunately, for those looking to catch one, it's not as easy as you get an eclipse somewhere every time you're as far as possible from the sun, or the moon is as close as possible to Earth. A total solar eclipse is reliant on a perfect ratio of the distance to the sun versus the distance to the moon, and without them aligning just right, a total eclipse won't happen. The moon also needs to be in the new moon phase for a total solar eclipse to occur. There are actually two main types of eclipses, solar and lunar. We'll touch on lunar eclipses in a moment. Solar eclipses are what most people typically think of when talking about eclipses, when the moon passes between the Earth and the sun, and a shadow is cast on the Earth by the moon. The two main phases of an eclipse are partial and total. A partial eclipse occurs when only part of the sun is covered by the moon, so some parts of the sun are still visible. This is the part of Earth that's within the fringes of the shadow, where it's not quite as dark. However, when the sun is completely blocked by the moon, that's considered a total solar eclipse. The path of totality, or the shadow, is around 100 miles wide, so only a limited region will be under a total solar eclipse when it occurs. The third type of solar eclipse is called an annular eclipse. Because of the changing distances between the Earth, the sun, and the moon, sometimes the moon looks smaller than the sun, which prevents it from fully covering it. This happens when the sun is more near to Earth and the moon is at or near its greatest distance from the Earth. This results in a ring around the moon since the sun's not completely covered. You'd think that eclipses would happen pretty often if it takes less than a month for the moon to orbit around the Earth, right? Not exactly. Solar eclipses of some kind occur every 5 to 6 months, with a total solar eclipse happening somewhere on Earth every 18 months on average. But they're often over the poles or the middle of the ocean and thus are not visible to us on land. At any one given point on the planet, a total solar eclipse will occur on average once every 400 years. Lunar eclipses are kind of opposite to solar eclipses. Instead of the moon's shadow projecting onto Earth, during lunar eclipses, the Earth projects its shadow onto the moon. The three types of lunar eclipses are similar to the types of solar eclipses, with a total lunar eclipse meaning all of the moon is within the darkest part of the Earth's shadow, and a partial lunar eclipse meaning only part of the moon is within the darkest part of Earth's shadow. If the moon is only within the fringes of the shadow and not under the darkest part of the shadow, it is called a penumbral lunar eclipse. These are very faint because the Earth's penumbra is not very dark, so they're difficult to see. At any given point on Earth, lunar eclipses happen on average once a year. Now that we've gone over definitions of the types of eclipses, here's an illustration that might help you understand them a little better. On the bottom, you can see that for a total solar eclipse, the darkest part of the moon's shadow, or its umbra, is very narrow, which creates that very small path of totality. The broader part of the shadow, the penumbra, has a much wider footprint, which is why some places may see partial eclipses but never reach totality. It's also possible for the Earth to be under the penumbra, but none of the umbra would fall onto Earth. For example, if the moon were a little further up in the diagram, which would still be considered a partial solar eclipse. If the moon were to be closer to the sun than shown in the diagram here, the umbral cone wouldn't reach Earth, and so sunlight would leak, so to speak, around the edges of the cone of the umbra. That is why the annular eclipse has a ring around the outside of the moon. In contrast, the lunar eclipse diagram at the top shows that all of the moon is within the darkest part of the shadow, which means the viewing area from Earth will be much larger than a solar eclipse. Usually, a total lunar eclipse can be seen by the entire hemisphere on the night side of Earth when it happens, which is why it seems like lunar eclipses are more common, even though they happen around once a year on average at any point on Earth. What would a Weather Service presentation be without some safety information? When watching solar eclipses, it's very important for your eyes to be properly protected to avoid damage. The only time it is safe to look directly at the sun is when a total solar eclipse is at complete totality. If you're not in the path of totality, it will not be safe to look directly at the sun, even if it's mostly covered. That goes for annular eclipses as well. That being said, you can watch a partial eclipse if you have specialized eclipse glasses with a proper filter on them. Sunglasses are not properly filtered for looking at the sun directly and are not substitutes for legitimate eclipse glasses or solar filters. Even if you have filtered glasses on, you should never use binoculars or a telescope to look at the sun. These devices require their own filters designed to handle magnification of the sun's rays. Bottom line, if you plan on watching a solar eclipse, make sure you have proper eyewear. The moon isn't nearly as bright as the sun, so eclipse glasses usually aren't recommended for watching lunar eclipses. Some other fun facts about eclipses. The National Weather Service office in Lincoln, Illinois observed a 4-degree temperature drop during an eclipse in 1994, and a total solar eclipse in Zambia in 2001 observed a 15-degree temperature drop during totality. This does depend, of course, on how long an area will be in totality, because the temperature will drop more if you're under the umbra longer. On average, totality will last anywhere from 2 to 6 minutes in one spot, but the umbra will be visible on the Earth's surface for around 3 hours as it moves through its path. The shadow moves over 1,000 miles per hour, and when totality is over the poles, it moves even faster due to the apparent speed of Earth's rotation near the poles. That's going to conclude today's video about eclipses. As always, if you have any questions, feel free to reach out to us on social media or shoot us an email. Thank you for watching, and hopefully you learned something.